Good day. Mole conversions continue. If you hear some chomping in the background, that's Wolfie doing something that he rarely does, and that's actually eating his dog food instead of human food. It looks like he's taking offense to that. We just showed you a video with 6 examples of these conversions, and this one has 6 more examples. Unfortunately for you, you will have to copy them out, including the questions. Things to have handy: periodic table and the conversions chart. And remember, you must have respect for significant digits. We love questions, moles to particles, because it's a one-step deal. Here's our molecules, happens to be of CO2, 7.5 moles. And we want to know how many particles. Well, first thing we should know is it doesn't matter the identity of the particles. If 7.5 moles of lead, 7.5 moles of water, 7.5 moles of carbon dioxide will all have the same number of particles. So we take that 7.5 moles CO2, we multiply by Avogadro's number, and we say, hey, we got to get a number bigger than 6.02 times 10 to the 23rd, and we do. 4.5 times 10 to the 24th molecules of CO2. We're going to undo what we just did, moles to particles. Now we are going from particles to moles. And we see we have a large number of atoms of copper, so we're going to write that down. And we're going to divide by Avogadro's number. And we're going to see, what do we get when we divide? Well, that is going to be a lot of moles. Not surprisingly, times 10 to the 4th moles, because 10 to the 28th is a lot bigger than 10 to the 23rd. So those conversions were between the two left parts of your conversion chart. Now we're doing moles to mass, so we're operating between the middle and the right of your conversion chart. We're given the moles, and to go to mass, we know we multiply by molar mass. We look up zinc on the periodic table, and we get a number slightly smaller than 65.38 grams per mole, because it's slightly smaller than 1. You should always have an idea about where the answer should be. You should estimate. You should not blindly trust your calculator. Now, next one's going to be a pain. And the pain is we don't have an element. It means we've got to, first of all, figure out the formula for copper 2 bromide, CuBr2, and then we have to get its molar mass. So there's how we get our molar mass of copper 2 bromide. 223.35 grams per mole. Then we're going to write down this number of grams, and if we're heading to Moleville, we know that we have to divide. So we're going to take this number given in the question, 1,000,000 grams of copper 2 bromide, and we're going to divide by this number of grams per mole, and we know we have to get a number way bigger than 1. And in fact, it's almost 4,500 moles of copper 2 bromide. Those examples should be simple. This tells us on the next page, we are looking at two-step processes. We are looking at going from particles to mass or mass to particles. It says, what's the mass? So we're aiming for the right, and we're given the molecules, so we know we're starting on the left. So we got to go molecules to moles, moles to mass. Well, molecules to moles is no sweat. We take the number given the question and we divide by Avogadro's number. Our units are molecules per mole because we're talking about molecules. If I wanted atoms, I would have to double because there's 2 atoms per molecule. Anyways, times 10 to the 21 is smaller than Avogadro's number, and that's why we get a small number of moles of oxygen. Now our next step is to take that number of moles and multiply by the molar mass of oxygen. The molar mass of oxygen is not 16.00 grams per mole. It is 32.00 because it's diatomic. And we get 0.272 grams of oxygen, O2. 2 steps, no sweat. Oh, now we get some of the more exotic. How many atoms are in 3.00 nanograms of gold? Now, nanograms are very small. But even though they're very small, we're going to be surprised how many atoms are there. So our first step is to go mass to moles. 3.00 nanograms. Well, let's just kick that into grams before we do that conversion. And so we get a tiny number of grams. We take that number of grams, and we know this is a gold, AU. We divide by the molar mass of gold, and we get a tiny number of moles of gold. And what we have to do is now take those moles and convert them to atoms. So we're going to take this tiny number and multiply it by a huge number and get a fairly big number. So even though we're down at nanograms, we still end up with trillions of atoms of gold. 9.15 times 10 to the 12th atoms of gold. And you can kind of guess what we're going to do next. Next, we are going to have you work on assignments related to these concepts. And you're going to get lots of practice so you can dominate this stuff.